Any questions about that before we move into unit conversion?
No, got it. Thank you.
Cool. So this first slide is kind of contains all the helpful conversions you might need for the class. I believe the first test gives you all the important conversions on the first page, so you wouldn't necessarily need to memorize it for the test, but it is a good idea to kind of have these down in your notes because we'll reference it obviously this week and probably at points throughout the semester. So we have length, we have capacity, we have weight and mass, and we have time. So these are all the US or imperial conversions. And then there's also metric conversions, which we'll cover as well. They're actually very nice to convert. This, hopefully it shows up, there we go. This table kind of talks about those things that the precursors before each term. So if we have grams, we have kilograms, we have decigrams, we have milligrams. If we have meters, we have millimeters, we have kilometers, everything like that. So those are the things that go before these. We call them base units, and meter is always our length, liter is always our capacity, and gram is always our weight and mass. So we're going to use that idea of rates when we're talking about these unit conversions. Like I said, it's sometimes referred to as US or imperial because we're not the only country that uses it. We're just one of the very few that use it at this point. So if I want to go from 2 feet to inches, I start by setting up that same thing that we saw in those rates, those 2 feet over 1. And then I go back to my conversion chart and I can see, okay, 1 foot has 12 inches. So that's my second fraction that I'm going to set up. I want to cancel my feet. I want to be left with inches. So that's 12 inches over 1 foot. I can cross cancel, and I'll be left with my goal, which is 2 times 12 is 24 inches. See this with a different distance unit. I have yards to inches. So in this case, there is no direct jump to go from yards to inches on our chart. There's a conversion from yards to feet, and there's a conversion from feet to inches. So we're going to have to set up multiple fractions. So I know that there's 3 feet in a yard. I know that there's 12 inches in a foot. So those where those fractions come from. And if I've set it up correctly, I'm going to have everything cancel, and I'm going to be left with inches. So we'll see that the yards cancel, we'll see that the feet cancel, and that we are left with inches. And then we just multiply again straight across. 9 times 12 is 108. 1 times 1 times 1 leaves me with 1. 108 divided by 1 is 108, and I'm left with the correct units that I'm asked for, which is inches. So now I have 36 inches to yards. Now I'm going to be going in the opposite direction. So it's not always that we're going to get bigger and we're always just going to multiply without fractions. In this case, I'm going inches to yards. Again, I don't have a direct conversion from inches to yards. I have a conversion from inches to feet. So I have to go inches to feet. I know there's 12 inches in 1 foot. And then I have a conversion from feet to yards again. If I've set everything up, I'll get that cross canceling, which we'll see. Multiply straight across, I'll be left with 36 on top, 36 on bottom. I go ahead and do 36 divided by 36. That'll leave me with yards because everything's canceled. So if you're setting it up correctly, everything should cancel and you won't get a weird unit like, I don't know, feet, yards, inches, or something like that. You should be left with 1 unit, and it should specifically be the unit you're looking for. So let's do 2 more, I believe. 2 or 3 more, and then I want you to kind of practice that on that in-class assignment.
Okay.
So going gallons to cups. So again, looking at that chart again, I don't have a conversion from gallons to cups. I have several conversions. So one of those is gallons to quarts. So quarts to gallons, I know 4 quarts in 1 gallon. I know that there is 2 pints in 1 quart. I know that there is 2 cups in 1 pint. And that's what I was looking for, was the cups. So yes, there's a lot of things set up, but if I've set it up correctly, we can see that things are slowly getting canceled. And I'm left with the correct units I'm looking for, which is cups. I multiply straight across. 2 times 4 is 8, times 2 is 16, times 2 is 32. So I'm left with 32 cups. Last conversion for the US is time. So if I'm going from days to minutes, I know that one day has 24 hours. So I set up that fraction the exact same way that I've set up the other ones. I'm trying to cancel out my days. So I say, well, there's 24 days in one, or 24 hours in one day. 1 hour has 60 minutes. Again, everything cancels. You can multiply straight across. 5 times 24 times 60 will leave me with 7,200 minutes. So I'm going to pause the session for a little bit so we can practice these ideas. If you're watching this section or the lecture on your own, maybe pause it on your own and see if you can work through some of the weekly assignment. Okay, so we're going to move on to unit conversions and metric. It's not a super tricky subject. It's actually a lot easier than doing the US and imperial. It is helpful to kind of use that chart that we saw in the unit conversion table, which had the kilo and the hecto and the milli to kind of set it up. So let's bring that back up here.
Mm-hmm.
So that's kind of the breakdown of it, kilo being the biggest, milli being the smallest that we'll see in this class. There is bigger and smaller units. So we're going to see a couple of examples to use these conversions, metric conversions, not videos. I don't know where that came from. Okay, so let's say we have 23.2 DAM. Those are decameters. So I have 23.2 decameters, and I want to convert it to centimeters. So this is actually very similar to those scientific notation problems. So I'm going to copy over my 23.2, and then I'm going to see that, okay, I have decameters. That's my starting point. So I'm going to go back to my chart, start with my decameters, and I'm going to say, okay, I want to move that guy over until I get to my centimeters. So we'll see a jump from deca to our base, which is either our meter or liter or our gram, in this case meter. But we want to get to centa, so we're going to have to jump a couple times, and we're left with that centimeter. So that's actually how many times we want to make our decimal place jump. So coming back to the problem to the bottom left, we take our decimal place and we move it 1, 2, 3 times. And then wherever there's a blank spot, we fill it in with a 0. So I have 23.2. I moved my decimal place over twice, and to compensate for that, I'm going to fill in with 2 zeros. So I'm left with my actual answer, which will be 23,200 centimeters because I moved that decimal place over.
Mm-hmm.
So let's see that with another example. So in this next example we're going to go from milligrams to hectograms. There we go. So again, I copy down my number. I look at my chart up top. I want to move my decimal place the proper amount of spaces. So if I have a whole number, my decimal place is always after the very last number. So it's going to be the very farthest number to the right. So I go up to my chart again. I see that I start with my milligrams and I want to go to my hectograms, my HGs. So I'm going to have to do those jumps. 1, 2, ideally 3, there we go. 3, 4, 5. So I have to make 5 jumps. So again, as I mentioned, the decimal place is to the right of the number. So we're going to jump those 5 times. And that's where my decimal place will go for my answer. So my answer is 0.24314. Yes, I'm adding in that extra 0. That's more of a placeholder. Technically, you could just write decimal 24314. It's a good idea to put that 0 so we kind of have that space and can easily spot that measurement. Feel good about that?
Yeah, got it.
So it's fairly simple. I didn't really put anything on the worksheet for it. I believe it is a section on the homework, but it should go very quickly because it is that idea of just bouncing back and forth. Okay, finally, we're going to combine the ideas of going from imperial to metric. So our first example, we're going kilometers to miles. So we'd set it up again. I'm going to give you the conversion from these metric ones because there's only specific ones we want you to use. If it shows up on the test, busy. If it shows up on the test, I will give you the amount for those conversions as well. So again, don't feel like you have to memorize anything like that.
Okay.
So we are going to set it up like we set up the very first conversions, 5 kilometers over 1. 1 mile is equal to 1.609 kilometers. I cancel out my kilometers. I'm left with 5 over 1.609 miles. And then I go ahead and divide that through. I get 3.108 miles. So that's just, it feels exactly the same because the jump from metric to US is immediately. So it should look exactly like imperial, where we're going to see a couple examples where we might have to kind of shuffle around in metric before going to imperial and vice versa. So very similar to the first example, we have gallons. There's a direct conversion. I'm giving you the direct conversion from gallons to liters. So I know that there's 3.785 liters in 1 gallon. I would cancel out my gallons, multiply straight across. I'm left with 15.41 liters. But I'm not always going to give you all of the direct conversions. So one of the more famous conversions is inches to centimeters, because we actually have an exact conversion for that. So we'll see that here. There's actually 2.45 centimeters to inches. Those last two examples, those are approximations, where this is exact. So we are going to convert from inches to centimeters. That's our first step. So we cancel out our inches. We're going to be left with 7.62 centimeters. But notice that I'm not looking for centimeters. I'm looking for millimeters. So I have to do an additional step of converting from my centi to my millimeters. So I'm going to pull up that chart again. I'm not going to pull out the full chart, just kind of the part that we need. So the chart that we're going to need is we're going from centimeters to millimeters. So I'm going to make my jump of my decimal from centi to milli. That means I'm going to move it to the right. So I will have to do that as well in my answer, leaving me with 76.2 millimeters. Feel good about that?
Yeah, got it. Thanks.
Yep. Okay, so one more example, we're going millimeters to inches. So again, we're going to use that idea of we don't have a direct conversion, but we have a conversion of inches to centimeters. So if I know that conversion, it doesn't help me to have it in millimeters. So I have to make my first conversion in metric first. I have to change my millimeters to my centimeters. So I'm going to move my decimal place over once. And again, since there's no decimal place, it's after that number furthest to the right. That 20 millimeters becomes 2 centimeters. And now I can use that conversion that we saw in example C of going from centimeters to inches. So I have 2 centimeters over 1 inch. I'm going to multiply that by 1 inch over 2.54 centimeters. I'm going to cancel out my centimeters, and that's going to leave me with inches. I would multiply straight across, and if I get 2, I do 2 divided by 2.45, and that will leave me with my answer of inches. Okay, so let's see the application problem of this. I don't know why that loaded weird. Okay. So a recipe calls for 64 ounces of butter. If one stick has 1 cup, how many sticks will I need? So I can't really answer that question until I have my ounces in the amount of cups, or I have my cups in ounces. So I'm going to say, okay, if I have 1 stick and that's a total of 1 cup, how many ounces do I have in each of those sticks? Well, I can go back to my unit conversion chart and I see that 1 stick is equal to 8 ounces. I can cancel and I have 8 ounces. So if I know that each stick has 8 ounces, then I can say, okay, if the recipe needs 64 ounces, I have 8 ounces per stick. Divide those out, I have 8 sticks of butter. Let's see another example. This recipe calls for 2 pints of milk. So I'm going to load again. There we go. If each bottle has 4 ounces and you buy 12 bottles, do you have enough to make the recipe? So again, it's kind of difficult to visualize this problem unless we have it all in the same amount of units. So I know that I have, each bottle is 4 ounces. I know that I have 12 bottles. The question is that going to meet my requirement of 2 pints of milk? So I say that I have 12 bottles. I know that each bottle contains 4 ounces of milk. But again, I want to compare pints. I don't want to compare ounces. So I do have to have that additional step of converting that ounces into cups, and then converting the cup into pints. So it is a big setup process, but if we've done our setup correctly, we're going to see our bottles cancel. We're going to see our ounces cancel. We're going to see our cups cancel, and we're going to be left with our answer of 3 pints. If we multiply straight across, to see that, we would do 12 times 4 is 48, divided by 8 gets me, oh no, divided by 16 would get me 3, because I have that 8 times 2 in the bottom. So I have 3 pints, but I'm still not really answering the question. The question's asking, do I have enough milk with my 12 purchased bottles? And the question is yes, that will actually be enough milk. So I did the math, and that is the correct answer, or the correct amount, 3 pints. But the question's asking, will you have enough milk? So to properly answer the question, you do have to state, yes, there will be enough milk.